Hello everyone, I am Harshit. Before we start, I want to explain why I'm making this. I went looking for a course that teaches the technical side to non-technical people, product managers, founders, marketeers, operational people, procurement, but I couldn't find one. And in my office, I've been seeing this new thing where people are whiteboarding different things, but they don't even understand what a database is, what is a load balancer. So in that case, I wanted to create a course which is exactly at the right level for everyone so that people can understand to a level where they can understand basic terminology for computer engineering, but also do not need to basically dive deep and understand writing piece of code. So this is somewhere in the middle. It's not too deep, but it's also not very shallow. So you will be able to understand enough so that you can talk to your engineers and ask sharp questions about your product which you are working on. And honestly, like with AI coming in, everyone has been impacted by AI. The line between the technical and non-technical people is getting blurry. And people who understand how the machine works underneath are the ones who will make good calls. So that is why I have designed this course. So let's start with how a software works. By the end of the series, the idea is you should be able to form a mental model, a clear character picture of how software actually works. So you should be able to see a particular software and then should be able to understand that I clicked here, this went to this particular component. From this component, the request went to the next component. So once you have this in your head, the jargon stops being scary for you. And it will be very easy for you to interact with your engineers as well. So let's start with software, how it works. So let's start with this thing which I have written here. I want to highlight this. This is the most important part of this journey, that you need to understand that a software is just instructions acting on data. So let's start from here. So let me give you a single most important sentence in this entire series. If you remember nothing else, remember this. Software is just instruction acting on data. Instructions are basically the steps which the software needs to follow. And then the data is the input which we give to the software. It could be some other kind of input which might be stored somewhere. But at the end of the day, it's just some kind of stuff which the software works on. Every app, every product which you have ever worked on, ever shipped, it basically uses the same kind of journey. And it happens like billions of times in seconds. So you're not able to observe it, but all of it works in the same manner. A click leaves a device, travel across a network, reaches a server, runs some logic there, touches some stored data, and sends it back to the screen. That's the loop, and that's the heartbeat of basically everything in software engineering. So here I have shown a typical diagram of how it works at a very high level. Currently, you won't be able to understand it in like depth, but as we progress forward, you will be able to cover everything. So as I was mentioning, first we will go wide and shallow. So we'll just understand what exactly everything is. We'll just try to understand the analogy on how software works. And then we will come back and go in depth of each kind of component, how it basically impacts the whole software. So I have taken this analogy, right? So let's imagine a restaurant. This is a small restaurant. You can feel this is the dining area which you have here. And this is kitchen and the back room. And this is the manager area, right? This is the restaurant. Just think with me or try to picture what I'm trying to explain you. Let's say this is the customer and this is you. There's a menu, the things you're allowed to order, this menu card, and the waiter takes your order to the back. So this waiter will take order from you and give it to the kitchen. There's a front counter here in the kitchen. Generally, if you have been to a restaurant and have seen the front counter, there is a front counter where they have some stuffs, some basic ingredients which are important. So like salt, pepper, which are used in nearly every recipe. And then you have the chefs here. And then you also have all the requests coming from here to the front counter. Then there is bunch of recipes which the cook has. Basically, these are all written recipes, but over time, the cook can recall it. But he has like multiple instructions with him, which he can follow to create a particular dish for you. And then there is a storeroom where you have all the ingredients for it. So every night they will take some stuff out of it. If there is some dish which requires a particular kind of stuff or particular ingredient, the chef will go to the storeroom and bring it from there. Right. And then you have a manager here. So this is the manager. So what the manager does, he basically keeps an eye on the whole floor. Okay. Now let's start to understand how it works. As I said, let's say you are the customer, you give an order based on the menu to the waiter. The waiter went to the kitchen and gave it to the chefs. The chefs was able to prepare a recipe for you based on instructions given to him or built by him over time. He took some ingredients from the front counter. He took some ingredients from the storeroom. I built you a recipe and then gave it back to you. Meanwhile, the manager was keeping an eye on you to make sure in the dining area that everything is going fine. Now let's come to this second picture. So this is the analogy I'm trying to explain to you. The customer is the user. So the customer is the user. The menu is the API. So the list of things you can actually allow to ask for. You can't order something that's not on the menu. So for example, you can't order a message from Uber. You cannot order something like a laptop or a MacBook. You need to go to some other Amazon, for example. So there are a bunch of features, bunch of APIs available with you through which you can basically request anything from the waiter. So the waiter is the network. He basically takes request from you and then take it to the kitchen. The kitchen is the server. Here, the real works happen. The chef receives your request and then create a recipe for you or an output for you, right? So this is what the kitchen is. And then when we talk about the storeroom, this is the database where we have stored all the ingredients. So the chef gets all the ingredients from the database, but for some of the things which are very necessary for him, he will keep it in the front counter and he can directly use the stuff kept right up front because he knows that it is being asked for constantly. So you don't need to run to storeroom every once in a while. You can just pick some stuff like salt, oil from here directly and use it for the recipe. And the manager who is watching over all of this is basically a monitoring service. You request something based on this menu. You request something to the waiter. Then he takes that request. He gives it to the now server can get some data from the database, but also from the front counter, which is the cache. And then once the recipe is already created, then you will take it to the waiter. The waiter will come and deliver it to you. And a manager will keep an eye on everything happening. So that's how it works. Now let's come to understand what exactly a software is. So the software is instruction plus data. In restaurant terms, the recipe plus the ingredients. The recipe is the logic, the precise ordered steps. The ingredients are the data, the steps act on. Neither one is useful alone. So you need to have both things. For example, if let's say you have a recipe and you don't have the ingredients, how you will basically create that dish. So to have that dish or to have the chef cook it for you, you need to have both. He needs to have the instructions and the ingredients to build the dish for you. So a pile of ingredients with no recipe will just be groceries. It won't be a final dish. Now let's just focus on two things. I have mentioned some of the terms which you might have heard. If you have worked in tech, a few of the terms, or even not in tech, you might have heard somewhere. So first is the program. A program is nothing but is a recipe written down. It's as simple as that. A file of instructions sitting there waiting to be run by someone. It's not doing anything yet. It's a recipe card in the drawer with the chef. A process is what we call that recipe when it's actually being cooked right now. Same recipe, but on the stove, steam coming off it, actively running. Program is the card, process is the cooking. That's the difference, okay? So that's what I have tried to explain here. A program is simply a written down recipe, okay? When the computer is actually running the program, following the steps right now, we call that running through a process. So if you go to your computer and if you are on Windows, I think it's Control Alt plus Delete and you can go there, you would be able to see a bunch of processes ongoing. So these are multiple programs which are running, and you can call those as processes. Now let's talk about the third thing. This is algorithm. So if you have ever thought of learning tech, you might have heard about DSA, which is very popular for all the programmers. So algorithms are nothing, but it is just a recipe though, but it's a clever recipe. It is just set of instructions which need to be followed by the system. Why database is not hard coded, right? So let's say why the ingredients don't live in the recipe. That's what you're trying to ask, right? Because if you have a database, if you have data, you can just add it to the instructions and run it, which is, by the way, possible. It's not like you cannot hard code some of the data, but why it is not generally done that way? The ingredients, the data need to be stored, protected, and findable long after any single dish is cooked. So think about it. Let's say one program stops running and you have your customer list, your orders, your account balances. These stuff saved need to outlive the moment. They cannot just stop with the program itself. A recipe can get used and finished, but the storing room needs to be open tomorrow as well. So that's the idea. So we keep them separate, a recipe in one place, ingredients in another. And that separation just isn't like to make it clean. It's one of the most single useful idea for a PM in the whole discussion which we will have, right? So now I will come to this part, right? Let's say there's, as I was mentioning, that you need to keep the instructions, the recipe and the logic isolated from the data. So why it is important? It is important because of a change. So let's say tomorrow you want to make some changes to your system. Now think about it. If you want to make some changes to the system and then you go ahead and make changes to the logic, it's much easier for you. You can change the recipe. It's just a piece of paper. You can make the changes in 2 minutes and you can give it to the chef. He can read it so he can understand everything in 10 minutes and can start cooking after that. If he's an experienced chef, it will be very easy for him. But doing the same thing with the ingredients which you have in the storeroom is very difficult because some of the ingredients are being used at the same time when you are receiving the order. So it's very difficult for anyone to reorganize the storeroom while the restaurant is open. So it is far more delicate and risky. That's why there is an isolation. So you can change the code, but you don't need to change you don't need to basically have any impact on the database. So that's the idea why we segregate it out. So yeah, let's say we have an issue with the recipe. So the recipe said that you need to boil eggs at 130 degrees Celsius, right? And the recipe was for soft boiled egg. And the recipe said that you have to boil it for 20 minutes. But the soft boiled egg would be probably at 80 degrees Celsius for 8 minutes, right? So there is some problem with the instructions given. And due to that, the output would come out as wrong. The output would be a spoiled or a hard boiled egg when the customer or the user wanted a soft boiled egg. So these problems or these spots in the instructions where something went wrong are called bugs. It can also happen that, let's say, you were trying to boil the egg, but you brought a ostrich egg instead of a hen egg. Then it becomes a problem again. So if you have a chicken egg, then it would be much easier for you to boil it at, let's say, 80 degrees. But if you bring a ostrich egg and then you follow the same recipe, even then you won't get a soft boiled egg. So these are some of the differences. So your data also needs to be correct and then your instructions also need to be correct. If there is any problem with either of these two, then you see a problem or a glitch in your software and that is called a bug. So you need to keep that in mind that software does not create a mistake. Mistakes are only possible in the instructions or the data received. There could be some problems with the hardware, that's possible. But as a software, it exactly does what it's told to do, right? And you might have heard a word called edge cases. So what edge cases means that there are some, let's say, there was some rare combination of ingredients which the recipe did not account for. So let's say you want a fish from a particular lake in Norway and you did not account for that and then you're trying to create a dish and then something goes wrong. So these are like edge cases. You never thought about it, but when actually you started cooking that dish, you figured out that this combination won't work. So something like that happens, and those are called edge cases. I think that's good for today. So yeah, thank you everyone.